Welcome friends to the session of correlation regression. We are continuing from the last session where we did with correlation, right. So, in correlation we understood about what is correlation basically. It is a standardized covariance model basically, right. So, where we are saying that when the covariance which is basically the we say the covariance right, a correlation we said is a covariance, right. R is equal to R, which is the correlation, is equal to covariance divided by standard deviation of x by standard deviation of y. So, this is we said, right, and it is very helpful in several ways to understand the relationship between x and y, right, where x and y being the two variables independent and dependent. Okay. But we were also talking about something called R square, right. What is this R square? R square is nothing but the square of the correlation value, right. Now, the square of the correlation R square means that when suppose our R is equal to, let us say 0.9, right, in our last case it was something around 0.93 or something. So, let us say R is equal, that means the relationship between when two variables is 90%, right, our explanation power, that means R square is equal to 81% or 0.81. This says that the explanation power of the independent variable in the dependent variable is 0.81 in this case, right. So, that is a very important analysis, it is very useful as an analysis. And I would tell also that one thing, that through a correlation also helps you in checking a hypothesis, right. Correlation also helps you in testing a hypothesis and through the same method we will see. So, this R square that you just saw is called as the coefficient of determination, please remember it, coefficient of determination. Today we will go into, in this session we will discuss about something which is highly connected with the correlation, right. So, that is why in most of the books or any place you will see it is correlation and regression. In correlation we were trying to measure the relationship between x and y, right, what is the relationship between x and y. But what if we want to know how much is the change coming in y because of the change in x. Suppose you want to create a relationship relationship. So, to do that we would use something called a regression equation, right. So, regression basically, if you can see, correlation tells you that there is an association between x and y, right, but it does not describe the relationship, okay, it does not describe the relationship, but that is what we do in the regression. So, regression equation is equal to y is equal to, where y is the dependent, is equal to a plus bx, right. This is a very simple equation. Suppose you have more than one variable, then y plus b1 x1 plus b2 x2 plus goes on till bn xn, right. So, the change in y due to the change in the variables, independent variables x, x1, x2, x3, x4, xn, right, is what is of foremost importance to any researcher, right. So, y helps in understanding, it is helping in predicting a lot of things in life, okay. As I was speaking about stock let us say the share value, will share value change due to an announcement? Will share value change due to an announcement of a new product, let us say a change in the company's chairmanship, or let us say another variable is the fight between the company employees, right. Will those affect the final outcome of the share value? Now, we do not know, we can check that, okay. And the coefficients that we get, the coefficients are basically the, you can understand as the slopes basically, the coefficients, the beta coefficient basically what comes is that tells us how much is each independent variable having an effect on the dependent variable, okay. Now, before we go that, let us go to the last diagram that I had drawn, right, which is very important. Now, what was that? We were explaining about something called the variation, right. Now, we saw that there are two things. One, this is the mean, the mean of the value, right. Then we have something called this is the something the predicted value or predicted, this is the predicted y hat, we say estimated or predicted, right. So, this is the y is equal to a plus bx. Now, what is this b? The b is nothing but this slope, right. The slope is the b. What is this a? The a is the intercept. Now, intercept means intercept is a constant a, right. So, this constant tells us ki, that means what? So, if you understand this way, suppose x is equal to 0, then y is equal to a, right. So, this constant is that value when the independent variable does not exist, okay. So, to understand, okay, yeah, from here then we said ki if there is a, let us say y, let us say this is a I. Now, we said there are 2-3 things that we need to take, right. So, what are these? The total variation in this case is equal to SSY, we say is equal to yi minus y bar, right, square, okay. This part I had explained is called the unexplained or the unexplained error, or sometimes it is called as noise, residual, whatever way you can explain, right. So, this is something, what this part is our explained, right. So, explained, or we say so this is the explained part, right. So, now the total variation. So, now when we are trying to say when we are trying to measure any regression equation, we are interested to understand ki how much of explained variance is there, how much of unexplained variance is there, right. So, what we are doing is basically we are trying to find out, we are actually finding out the explained variance upon the total variance. We are interested generally in the explained variance and the total variance. So, sometimes you can also make it like this, ki that means what, total minus unexplained or error, right, divided by total, okay. So, let us see this. The aim of this is very important, the aim of the regression line, why is this, why the regression line is also called as the best fit line, right. If you see this, now this is called the best fit line. Now, best fit line, because if you draw any line, there could be infinite lines, right, you could be drawing infinite lines, but the point is why only this line is called the regression line, because let us say there could be infinite ones. So, but why only this bold one, right, why this bold one? Because this line has the minimum deviation, that means if you take the dots or the values, the observed values and find out a standard, the variance, then you will see that this line has the minimum variance, right, the variation of the value, the summated values of all the datas, the minimum variation comes in when you use this line, right. So, that is why it is also called as the best fit line, right. So, so y estimated, if you can see, is the predicted value, yi is the true value which is the observed value I had said, and e, if it is visible or not, e is my residual error, right. Okay. So, so the question is, if I am talking about the regression equation, so y is equal to a plus bx, right. So, that means what, I want two things to know. So, for a given value of x, how much will be the y? To do that, we need two different values, that is the a and b, right. So, how much is the slope and what is the constant? If we know that, then for any change in x we can know y, right. So, the prediction becomes much easier, okay. So, let us see this, let us go to the regression analysis. So, there are few things that are very important. it examines associated relationships between metric dependent variables and also one or more independent variables, okay, right. So, it whether a relationship exists or not first of all. Next it says how much of the variation in the dependent variable is explained by the independent variables, that means the strength of the relationship. So, if you have several, let us say the coefficient which I said, the coefficient of the independent variable, the higher the coefficient, higher is the explanation power, right. So, if the estimate, it is if you look at the estimates basically say beta coefficient, the estimates, then we say the higher, the stronger the beta coefficient, the stronger is the explanation power, right. So, so these are the few things, these are very important, okay. So, let us go to the how to cover that, how to find out, right, that B. So, as I was saying, so B or that slope B is equal to the nothing but the covariance that means the covariance between x and y divided by the x square, right. It is what it is saying, B is equal to covariance divided by xy divided by Sx square, right. So, Sx square is nothing but the variance in the x value, right, the variance, right, it is the square, the standard deviation square of x basically, which is the independent variable, okay. Now, if we take this, we will get the slope, the B value, right. Now, let us break it up. Now, as you know, how will it look like, let us say. So, x minus x bar, I think you must be remembering, by into y minus y bar summation, right, divided by, so what was x minus x bar square, correct. So, this is what we want. So, if we have this, if we get this, then automatically we are finding out, we can find out the value of B, right. So, using this formula you can find out the value of B, right. So, let us take this there is a case, but before that once you have found the value of B, you can also find the value of A. Now, how much is A then? Now, we said y is equal to A plus Bx. So, A is equal to nothing but y minus Bx. So, to do that, when you have already got the value of y, what should you do? You just have to take the y mean and the x mean and use it for calculating A, and once you get the value of A and then you have got already the value of B, then what we can do is we can just measure any value of y after that, right. So, let us take a case, the same example we are holding, right. So, we said that the respondents, the attitude towards the city is our dependent variable, the duration of stay in a particular city is my independent variable x1, and this is my importance weather to the weather, which is x2. Now, I may be using 1 or 2, let me see. So, the intercept, for example, in this, now what did we say? Now, if you go back, this is also written as, so if you use this formula, right, you can calculate through this method. I do not like to remember things, but if you want to remember, you can remember. So, there is another way of understanding remembering this formula. So, as I was saying, so, so to have the predictability y is equal to A plus Bx, right, where x being the independent and this is the dependent. So, we need two things, the A and the B, okay. So, A is as I had explained, if you remember, right. So, suppose this is my y mean, this is the estimated regression, right, estimated y value, and this is the y is equal to A plus Bx, the regression line, right. And also we had also discussed why it is called the best fit line, right. So, and this is let us say my yi, the true value, let us say, or the observed value. Now, we have two things, this is the total, right. This is my explained part, and this is my up to this is my unexplained part, which I had already written, right. So, to this is the intercept we are talking about and the slope, right. So, the researcher needs to understand key to find out to predict the value of y, he needs to find out also the value of a and the value of b. Okay. Now, what does it say? The b value, the slope is nothing but the covariance xy of x and y divided by the only the standard deviation or the variance of x, the variance of x, right. Now if you look at this, now what is it becoming? Now let us see. So, if I write this, can I write this like this? Now, covariance of x and y is equal to x minus x bar, right, xi minus x bar into y minus y bar, right, divided by the x minus x bar square, right. So, summation of this will automatically tell me what is my slope, right. So, if I have got my slope, right, and if I can then calculate my a, right. So, let us see from here, even you can write this formula as something like this, because in books you will find them many a times like this. So, this is something like summation of xy minus n x bar y bar, right, divided by, right, summation of x square minus n x bar square, right. So, this is the same formula which will result to, right. So, let us look at this problem which is there, we have already done, right, once. So, let us look at this. So, what does it say? Now, attitude towards the city is our dependent variable and the duration of residence is my independent variable, and I want to predict what is the attitude of the residents for a city by taking into note or account the amount of time he has spent in the city, he has lived that in the city, right. So, what is done is A is, this is little upside because of my adjustments, not been able to do well. So, anyway, this is A is equal to y minus bx. Now, what it is saying, once you have calculated this b, right, then we also need to calculate a. Now, how do you calculate the a? Now, let us say y is equal to a plus bx. So, a is equal to y minus bx, right, but what value of y and x are we taking? We are taking the mean, the average of y and x, right. So, if you do this, then you can calculate the value of a. Now, using the value of a and b, now you can predict any value of y for any given value of x, okay. So, let us look at this case, right. So, what it is doing? It is to measure, it is what it has done, it has first calculated the xy as given in our formula, and which is 917. So, earlier I had to make a change because there was a slight change. So, this was looking like a 10 into 2, which because earlier it was a mistake because of the change in the slide. So, this is basically a square. So, x square. So, earlier it was looking like 102. So, if you must have by chance, if you have seen, do not get confused. So, 10 square, now look at this is this value 10 square plus 12 square plus 12 square up to 2 square. Now, this total is 1350, okay. So, we have got all our values. Now, x bar y bar is how much? Now, x bar, if you remember, we have calculated earlier also, x bar was or we can calculate from here 9 point something, 9.5 or something it was, I do not let me see, yeah. So, the x bar is 9.333 and y bar is 6.583. So, n is equal to 12. So, if everything is given to us, now we can surely calculate the you can calculate from here only, let us not go back. So, b is equal to 917, which is our this xy value minus n is 12. So, x bar into y bar divided by xi square, which is 1350, right, minus 12 into x bar, right. So, this value has come to 0.5897. So, by getting this value of 0.5897, that means b is equal to 0.5897. We obviously, as I said, you can put in the value of y bar was how much? Y bar was 6.5. So, y bar was 6.583. So, 6.583 minus A is equal to y minus bx. So, b was 0.5897 into x bar is 9.33 something, right. So, by doing this we have calculated the value of A is equal to 1.0793. So, that means if x is equal to 0, still the constant value of the constant is y is equal to 1.0793 that means, okay. So, by doing this now you can predict, suppose attitude y, estimated y is equal to A 1.0793 plus 0.5897 the slope given into multiplied by the number of years the person has stayed. So, in this case if the person has stayed for let us say so 1.0793 plus b is 0.5897, suppose the person has stayed for 30 years in the city. So, we can say y is equal to, that means how much? So, 1.0793 plus 35 almost 8, this is almost 18 not 18. So, you can deduct 1 maybe. So, something around 18. So, the attitude will be around 18 something 17 18. Now, let us go back to the table and see. So, if you look at the attitude is going to improve, be very high if I am taking the duration of residence. This is a very strong relationship that we are finding, this is a good strong relationship that we are finding, right. So, this is let us take one more problem, right. So, so as I was explaining this part, kindly check this. So, as I was saying, if you remember this total y, total regression, the total variation, right, the total variation. Now, this was the total not this one. So, this is the total. So, this was my total variation y bar. So, this is my, let us say, total variation. So, SSY is my total, this is the total, right, and this is my SSE, you can say, error, and this is my SSR, the regression. So, while doing any regression, the researcher is interested in these 3 variances, right. So, the SS regression is nothing but my estimated y was this one minus y bar, estimated y minus y bar square, right, and similarly you can find the residual also. Residual, what do you mean by residual? As I have already explained, that means this is something which you are not able to explain, the researcher is unable to explain. Now, why is he unable to explain? That is again a part of the study that one needs to understand, maybe he has missed something very important, or the way he has collected the data has been, there has been something, some anomaly, or could have been something which we do not know at the moment. But this explanation, and whatever the test you do, there will be slight errors always there, right. But if the unexplained variance sometimes dominates the explained variance, the whole purpose of the study will be lost, okay. So, if you see this R square, which I was earlier also explaining in the coefficient of determination. So, the R square is nothing but, it says SSR divided by the SSY, right. So, R square is nothing but is given by the explained variance divided by the total variance. If you, I hope you remember what I had said, R square is equal to, which is the coefficient of determination also, the explained divided by total. Now, what part of the total am I able to explain? So, this is what the coefficient of determination says. So, if you have a R value also, the correlation value, let us say of point, let us say 9, I said your R square becomes 81%, that means 81% you have been able to explain, which is the 0.81 which will come here, explained is 0.81, and the unexplained part which remains is the remaining, that is 0.19, okay, 19%, okay. Let us take one more problem which I have brought. Now, let us solve this problem. So, what I have done is, we will take a case where a company wants to find out is the relationship between 2 things. One is the amount of expenditure it makes in R&D against the total profit. So, that means, so what is my profit? Profit becomes my dependent and my R&D expenses becomes my independent, okay. So, he wants to calculate what is the, can I find out, predict what will be my future profit if I change my my R&D expenditures. Okay. So, to do that he has brought in some kind of a, you can say profit or sales, maybe let us say, not say profit, sales let us say. So, these are 50, we can say 50 million, 40 million, 30, 20 and 60, they are all randomly I have brought in. So, these are 15 expenditure in 15 million, let us say 12 million, 10, 10 and last is 18. So, can I do this? Let us, I suggest you also do sideways with me, along with me. So, my x, this is my, sorry, y. So, y bar is equal to how much? The total is 200. So, this makes 1, 2, 3, 4, 5. So, 40. So, y bar is equal to 40, x bar is equal to how much? Now, it has come around 65. So, x bar is equal to 13. Okay. What do I need? Now, I need the xi, xy basically, right. So, xy, if I do xi, yi, right. Now, how much it will come? Now, 15, 5, 750, this is 12 4 is 480, okay. This is 300, this is 200, this is 18, 6, 8, 48, 8, 4, 10, 1080, right. So, this total comes to 2810, okay. Summation of xy is equal to 2810, right. What else do we require? Now let us try to do it. So, if I am calculating B, I will have 2810 minus, what was my n is how much? Now, n is equal to 5. So, 5 into what was the next x bar, y bar. So, x bar is how much? 13 into y bar is how much? Now, 40 divided by, the whole divided by 893. Now, what is this 890? Okay, this is the x square. So, if you go back, I will written, we had said x bar, summation of x bar. So, x bar is equal to 225, 144, 100, 100, 324, right. So, this will become somewhere around 893. I have already done it. So, 893. So, 893 minus 5, right, 5, because we said the formula is n into x bar n into x square, right, x square is how much? Now, x square is equal to 13 square. So, if you do this, you are getting almost the B value is I do not know, you can do it with me, something around, I have already calculated. So, 210 by 48, I do not know my calculation, I have done it, just you, it might be wrong also. So, 2810, so the 4 3 is 12, 13 plus 5 20, 5 5 260, okay, 210 divided by 48, okay. So, something around this. So, 48, you can, if I, to make it easier, let me make it somewhere close to 50. So, 4.2, almost 4.2. So, my B is almost 4.2, and if my B is 4.2, what is my A? Now, my A, I am rubbing this off, I have no place. So, if my B is 4.2, my A is y bar was how much? 40 minus B is 4.2 into x bar was how much? 13, right. So, this is my A. So, this is equal to, this implies A is equal to 40 minus 13 4 is 52, 13 26. So, 54.6. So, something around minus 14, right, 0.6. So, now having these values of A and B, we can easily put it into the regression equation and can say ki if the company changes the value of x, the expenditure in R&D, whether he is going to increase his sales or he is going to decrease his sales, we do not know, we will have to put it, because every time we cannot say that the relationship would be directly proportional or positive, right. So, it will go on increasing, not necessarily. So, that is where something which is very important. But yeah, before I wind up this session, I want to tell you something. The R square that you saw, right, earlier, this R square is very important, but in research paper sometimes you will see that there is something called an adjusted R square also. Just I want to brief this also to all the listeners. You must have heard about something called a adjusted R-square. Now what is this adjusted R-square? Now R-square, as you can see, this R-square will go on increasing when you add up any independent variable, right. So if you have 3 independent variable and you are adding a 4th independent variable, the R-square value will increase. If you add a 5th one, the R-square value will still increase. But some variables actually do not contribute, right. And so what happens is, but just by adding a variable, although the R-square value increases, but the actually contribution does not increase. So what it does is, we have something called an adjusted R-square, which is very important. What it does, it takes into account only till that variable which, if you add, there is a growth in the explanation power. So after a certain stage, when you add a new variable and the growth in the explanation power does not change much, or it even falls down, then we stop there. So this is the value that you will see in many of the research papers which they cite it, which is called as the adjusted R-square, right. So this is something that I wanted to explain in the regression. Regression, as I have said, it is a predictive analysis which is used in almost all fields of science and management and everywhere, right. So where the researcher wants to predict by having through an independent variable, right. So if there is one independent variable, we are saying it is a single regression, simple regression. Suppose you have 2 or 3 or n variables, we will say it is a multiple regression, or multiple regression. So in those cases, the researcher has to understand what is the strength of the coefficients, right. The strength of the coefficients or the estimates, we say, basically will explain how much of how important is that particular independent variable to the final dependent variable, right. So this is all for the regression session. Thank you so much.